Welcome to solverfy.
Of some of the compounds given, and basically from there we have to calculate the mass percentage of a specific element present in those compounds. So to find out the percent of mass of an indicated element in a specific compound, we will use this formula. So from this formula we can see that mass percentage of a compound, the mass percentage of an element in a compound is basically the number of atoms of that element present in that compound times the atomic weight of that element over the formula weight of the compound, and we multiply that by 100% to get the mass percentage of the element in that compound. So let's start with the first example we have here. So in this case, we have to find out the mass percentage of carbon in acetylene, which has a formula of C2H2. So if we follow the formula directly, first we have to find out the formula mass of C2H2 and formula weight of C2H2 is actually the sum of the atomic weight of each atom present here. So let's start with carbon. The carbon's atomic weight is 12.01, and we have two carbons that therefore we multiply this by 2, and we have two hydrogen, and hydrogen has an atomic weight of 1.008, and we multiply by 2 again since we have two hydrogen, and this will give us a value of 26.04 atomic mass unit. So all these values we have here are in atomic mass unit, and therefore we will have the formula weight in the unit of atomic mass unit. And now we have to find out the mass percentage of carbon. If we write it in short terms as mass percentage of carbon, so it will be simply the number of carbon present 2 times the atomic weight of carbon, which is 12.01, over the formula weight of the compound, which is 26.04, and it will give us a value of 92.25%, and this is the percentage of carbon present in acetylene C2H2. Then we move to our next problem here, in which we have to find out the mass percentage of hydrogen in ascorbic acid. So the same way we can find out the mass percentage of H. So we have 8 hydrogen here. So we put 8 times the atomic weight of hydrogen, which is 1.008 atomic mass unit, and we put it over the formula weight of the ascorbic acid. And if we just find out the formula weight of ascorbic acid, um, just following the process we did in the previous problem, we will have a formula weight of 176.128 atomic mass unit for ascorbic acid, and time it by 100%, and it will give us the mass percentage of hydrogen as 4.58%. So this is the mass percentage of hydrogen in ascorbic acid. Now I have to find out the mass percentage of hydrogen in ammonium sulfate. So again, um, mass percentage of hydrogen. So how many hydrogen we have here? We have 4 times 2, 8 hydrogen. We time it by the hydrogen's atomic weight, which is 1.008 atomic mass unit. And in the bottom we have the formula weight of NH4 to SO4, which is 132.1424. If we just calculate it using the process we provided previously, we time it by 100%, and it will give us a value of 6.10%. So this is the mass percentage of hydrogen in ammonium sulfate. Same way we can solve this one, where we have to find out the mass percentage of platinum in PtCl2 NH32. So let's find out the formula weight for this compound here again. So the formula weight of PtCl2 NH32 will be, so the platinum's atomic weight is 195.078 atomic mass unit. Then we have 2 chlorine, and chlorine has an atomic weight of 35.453. And we have 2 chlorine that we multiply by 2, and then we have 2 nitrogen. Nitrogen has an atomic weight of 14.0067, and we have 2 nitrogen and multiplied by 2. And finally we have 6 hydrogen. 3 times 2 6. That means we put hydrogen's atomic weight, which is 1.008. Now we have to put AMU multiply by 6, and this will give us a value of 300.045 atomic mass unit. So this is the formula weight of PtCl2 NH32. Now we will use the um, same formula as before to find out the platinum's mass percentage here. So we can do that by simply putting, so since we have only one platinum, we will put just the platinum's atomic weight on the top, 195.078 mu, and in the bottom we will have the formula weight which we just calculated as 300.045 mu, and it will give us, and we time it by 100%, and it will give us 65.01% as the mass percentage of platinum in PtCl2 NH32. Then we go to our next one, where we have to find out the oxygen in estradiol. So in this case we'll just find out the mass percentage of oxygen. So here we have 2 oxygen, that means we place 2 times oxygen's atomic weight, which is 16 mu, and in the bottom we place the formula weight of this compound, which if we calculate we will be will find 272.3846 mu, and it time it by 100%, which will give us 11.75%. So this is the mass percentage of oxygen in estradiol. And then finally we have to find out carbon in this compound. So percent of carbon will be equal to, since we have 18 carbon here, we place 18 times carbon's atomic weight, 12.01 amu. In the bottom we place the formula weight of this compound, which is 305.4153, or it's 305.4153 atomic mass unit times 100%, which will give us 70.78%. So this is the mass percentage of carbon in this compound.